HTTP, Hypertext Transfer Protocol. HTTP is the language your browser uses to ask a website for a page. It's like texting your friend, "Hey, can I see your photos?" Then the server texts back with the image. It's fast, simple, and unencrypted. So imagine sending that text on a post-it note anyone could read. HTTP tells your browser what to fetch and how to show it. If anything goes wrong, bad address, missing file, it sends an error message instead, like 404, not found. Whether you're shopping online or reading news, HTTP is the unsung courier passing all those requests and responses. HTTPS, HTTP Secure. HTTPS is HTTP's secret agent cousin. It does everything HTTP does, but with encryption. That means messages are sent in a locked box that only you and the server can open. Often, there's a tiny padlock icon next to the URL to show it's locked down tight. It guards passwords, credit card info, and even your weird late-night Google searches. Without HTTPS, your data is like shouting your secrets across a busy coffee shop. Nowadays, nearly every site uses HTTPS. Browsers flag non-secure sites like they're wearing socks with sandals. Awkward and unsafe. DNS, Domain Name System. DNS is the internet's phone book. You type Amazon.com in your browser, but computers don't understand names. They use IP addresses like 54.239.28.88.85. DNS matches names to numbers, so you don't have to memorize strings of digits. It's like typing a restaurant's name into Google instead of dialing their number manually. When you visit a site, your computer asks a DNS server, "What's the number?" It gets the answer and connects you. Without DNS, the web would be a horror show of numbers. Thankfully, DNS takes it all away, until the occasional DNS not found nightmare. IP, Internet Protocol. IP works behind the scenes to deliver data to the right place. Every device on the internet gets an IP address, like your home address for the web. When a website sends you a response, IP ensures it arrives at your computer, not someone else's. There are two versions, IPv4, the old 4-byte addresses, and IPv6, longer, newer ones to fix address shortages. Think of IPv4 as standard street addresses, and IPv6 is more detailed GPS coordinates. IP doesn't guarantee performance, that's TCP's job later, but it makes sure your data gets sent to and from the right digital front door. TCP, Transmission Control Protocol. TCP is like a careful mail carrier. It makes sure every package, your data, gets delivered in order and without damage. Imagine sending a jigsaw puzzle piece by piece, and TCP checks if each piece arrived and fits in the right spot. If anything's missing or broken, it asks the sender to resend just that piece. It's reliable but slower because it double checks everything. Websites, downloads, and emails mostly rely on TCP to keep everything intact. UDP, User Datagram Protocol. UDP is TCP's chill cousin. It just tosses data out there and hopes it arrives. No hand-holding, no checking. It's fast, lightweight, and perfect when timing matters more than accuracy, like in live video calls or online games. If a data packet disappears, UDP shrugs and moves on. Imagine streaming a concert. If a few notes drop, it's fine, but if it paused to fix them, you fall behind. That's why services like Zoom or Spotify use UDP. It sacrifices perfection for speed, and sometimes that's a smart trade. FTP, File Transfer Protocol. FTP is the internet's moving truck. It shifts files between computers over a network. Whether uploading a new website or downloading software from a server, FTP gets it done. It's been around since the 1970s and still kicks, but it's not encrypted by default, so it's like shipping boxes with clear labels in a see-through truck. Anyone snooping on the road could see what you're sending. That's why secure versions like FTPS or SFTP are now preferred, but the core idea remains. FTP is the backbone of sending big chunks of data back and forth. SMTP, Simple Mail Transfer Protocol. SMTP is how your emails leave home. Think of it like the post office for your outbox. When you hit send, SMTP picks up your email and forwards it to the recipient's email server. But here's the catch. It only sends, not receives. It's like a one-way conveyor belt. To receive emails, other protocols like IMAP or POP3 step in. SMTP also isn't naturally encrypted, so it's often used with security layers like TLS to keep your emails from being read by nosy neighbors. Without SMTP, your inbox would be an empty desert. IMAP, Internet Message Access Protocol. IMAP is like your email inbox living in the cloud. When you check email on your phone, laptop, or tablet, and everything's always in sync, that's IMAP. It doesn't download your emails permanently. It just gives you a live view of what's on the mail server. Delete a message on one device, it disappears from all the others too. It's perfect for people who check email from multiple gadgets. In contrast to POP3, IMAP acts like a live control room, not a storage unit. It's how modern inboxes keep everything magically connected. POP3, Post Office Protocol v3. POP3 is old school. It downloads your emails to one device and deletes them from the server, like checking your physical mailbox and tossing the letters into a drawer. Once it's out of the mailbox, it's gone. Great when you only use one computer, but not ideal in a multi-device world. You delete an email on your desktop, but it still lives on your phone? That's the POP3 struggle. It's fast and simple, but not very flexible. IMAP basically stole its job and made it more modern. DHCP, Dynamic Host Configuration Protocol. DHCP is the thing that gives your device an address when you join a network. Imagine walking into a hotel and the front desk hands you a room key that works during your stay. You didn't have to set it up. It just happened. Same with DHCP. It assigns IPs so devices can talk to each other in the internet. No manual setup needed. Without it, you'd have to configure network settings every single time, like filling out paperwork just to get Wi-Fi. Nobody wants that. ARP, Address Resolution Protocol. ARP is like a phone book that matches names to numbers, but for networks. Devices talk to each other using IP addresses, but to actually deliver data, they need MAC addresses, hardware IDs. So ARP helps your computer ask, hey, who has this IP? And get back the matching MAC. Imagine trying to deliver a package in a big apartment complex. You know the unit number, IP, but need the actual person's name or door, MAC. ARP makes that connection fast and silent, all behind the scenes. SNMP, Simple Network Management Protocol. SNMP is the IT guy's walkie-talkie for managing devices on a network. Routers, switches, printers, even servers, they all have SNMP built in so they can send status updates or be configured remotely. It's like asking your printer how much ink you got, and it replies, "Cyan's low, buddy." SNMP helps admins monitor, troubleshoot, and even automate stuff. It uses tiny, structured messages called MIBs, Management Information Base, to get or set info. Super handy. Until someone misconfigures it and your printer starts snitching on everything. ICMP, Internet Control Message Protocol. You know that ping thing people use to check if a server is alive? That's ICMP in action. It's the messenger that reports back, hey, that site is up, or nope, can't reach it. It helps diagnose problems by sending error messages or echo replies between devices. It's like yelling, "You there?" down a hallway and waiting for someone to shout back. Tools like Ping and Traceroute rely on ICMP to map out problems in the network. It doesn't move actual data. It just tells you why your data might not be moving. NAT, Network Address Translation. NAT is the bouncer at your home router's door. Inside, all your gadgets have local, private IP addresses. But when they want to go outside to the internet, NAT rewrites their address to a shared public one. It's like everyone in a household sharing one phone number. When the reply comes in, NAT figures out who asked and routes it correctly. Without NAT, we'd run out of IP addresses fast. It's also a bit of a bodyguard, hiding internal IPs from the outside world.